I know bab crowd. Oh.
Is negative. This is not just any acceleration. This acceleration due to gravity. Okay. And if you've been following us for in class, okay, if you've been in class for a while now, by now you should know that if you are following us, you have this conversion. Okay. So anything that is any vector that is coming what down is going to have a negative what? It's going to be a negative vector. Okay. And we all know that acceleration due to gravity. And when you throw anybody up and it's coming down, G is always going to be what? Negative. Do you understand? So Scott, if you understand, just text me back, please. Now again, the object. Okay, Scott, just send me a text. Then again, the object was not thrown from the air. The object is it was kicked from the ground, so it's going up. So whilst it's going up, the velocity that is taking it up is the v naught y. Okay. But whilst it's going up, acceleration due to gravity will automatically bring everybody what? Down. Okay, so whilst v is going up, G is also bringing it down. Okay. Okay. Yeah, so yeah, I think hello. So Scott, click on your audio. Okay, Ziga says click on your audio and then you can hear. But I think I've addressed it. So later on you can watch the answer in the lecture video when I send it on YouTube. Okay, good. So let me move on. We don't have much time. Okay, so moving on, like I said, this is the S component of the velocity, the initial velocity. This is the Y component of the initial velocity. Okay, good. So having all this knowledge, we now want to do the resolution and then come out with the equations for the projectile motion. Now, when we look at this motion here, there are key characteristics which is of interest to everyone. The first characteristic is we want to look at the maximum height, the formula for the maximum height. So how far or how high can this object go? Let's say it's a ball. How high can it go? Okay, that will be your maximum height. So maximum height, sometimes you write it H maximum or S maximum. Okay, will be of interest to us. Then the next question of interest to us is what is the time it will take to get to what? The maximum height. That too will be of interest. Then the next question will be what is the total time of flight? Okay, what will be the time to get to the maximum height and the time to get back? Okay, that will be the time of flight. Okay, good. Now for the time of flight, somebody's video is on. So time of flight is going to be 2 times of the time to maximum height. So all we need is to find the time to maximum height. Then finally, we'll also be interested in how far the ball can go. Okay, how far the object can go, which will be the range. Okay, so we're also interested in what? The range. Okay, or let me put it in our technical terms, that will be what? The distance. So that will be the distance, okay, in the x direction. Okay, the distance in the x direction. Okay, so now let's begin and derive the equations for for these quantities. Okay, we want to derive the equations, the equations for these four quantities here. Okay, very good. So I think we've talked about all of this. So moving on. Very well. Yeah, so the first one is we have to take note that I wish I could create, let me create a page here. So that we can see how the equations came about, okay? So we said that in the y direction, y component, okay? Y component, we know that acceleration due to gravity is what? Constant, okay? So the acceleration there on the object is the negative g, okay, which is constant, which means that we can apply kinematic what? Equations, okay? And for kinematic equation, we have Vt is equals to what? V naught, okay, plus what? At, okay, which is the first equation. Okay, then we also have what? The third equation, which is V squared is equals to what? V naught squared. Are you with me at all? Plus what? 2a times the change in what? The change in s, okay? Then we have what? S final, okay, is equals to s initial, okay, plus what? Yes, if you are with me, give me the formula. So finish it out for me. Plus what?
Sir, S equal to V naught T plus half AT squared.
So you've left something. So you are supposed to have V naught T plus half what? Half, yeah, half A T squared.
AT squared.
Very good. So this will be the equations, okay? But because A is
Sir,
equals,
the S naught is it part?
yes, S naught is part. S naught. If you want to write it the other way, then it will be the change in S. Okay, the change in S is equals to this quantity. You understand?
Okay.
Good.
Okay, sir.
Yeah. So because our acceleration is acceleration due to gravity, which is negative, okay, the formulas will be modified a bit. So this now becomes V is equals to what? Let me clear that. So V is equals to what? V naught minus what? GT, okay, minus GT. Then the next formula will be V squared is equals to what? V naught squared minus what? 2GS. And then the second equation will be S is equals to S naught plus what? Plus V naught T, okay, minus half GT squared. Okay, so that is the equations we are going to use to derive what? The equations for maximum height, range, and then the time to maximum height. Good. Very good. Now we said that the velocity in the initial velocity, okay, in the y component, we are still in the y direction. The initial velocity in the y component, which is v naught y, I didn't write that well, so let me write it well. The initial velocity in the y component, which is v naught y, is equals to what? V naught sine of what? Sine of theta. Okay, which means that if we're looking for the time to maximum height, again, at maximum height, we made mention that at maximum height, your velocity here is what? Is equals to what? 0. Okay, so at maximum height, at S maximum V, your velocity final is equal to what? 0. Okay, which means that this velocity final here is 0. Then we also have the initial velocity here, which is going to be what? V naught sine theta. So we can write an expression for the time to the maximum height using equation what? 1. So that is going to be 0 is equals to what? V naught sine theta, okay, minus what? Minus gt. Okay, and then re-expressing this means we are going to get what? T is equals to what? V naught sine theta over G. Okay, so study it carefully whilst I take one comment. Okay. Yeah, it's not really a comment. Okay. So next point. So yeah, so we all got the formula, right? Give me feedback with the chat if you're okay. Just give me feedback, okay? Just tell me yes, that's all. Okay. Danny has confirmed that he's okay. Very good. So this is our first formula. So this is the time to maximum height. Okay, time to maximum height. Okay. So the next easiest thing we can find will be the time to total flight, okay, which will be 2 times of the time to maximum height. So that will be what? Capital T, total time, okay? Or let me make it easier for you. So we can make it T total, okay? T total. T total. Okay. Joshua has brought a question that why is G under V sine theta not negative? I think some of you are not following carefully. The reason why it's not negative is because we've already incorporated it in the formulas. We took our time to do that. We said A in the original formula now becomes negative G. So all the formulas have changed to negative because the G is what? Negative. So you don't bring another negative again. Okay, please follow carefully. Okay, follow carefully so that the questions that are coming will be more, tangible questions. Okay, good. So V total is just 2 times of the T maximum. Okay, so if you want the formula, that is going to be two times this formula here. Okay, which will be 2 times V naught sine theta over what? Over G. Okay, so that is how we get the time to what? Total flight as well. Okay, so moving on, we now want to find, we are still on the X component. So, sorry, in the Y, vertical direction. So let's find the maximum height, okay? That will be H maximum or S in the maximum direction, okay? So let's find maximum height. How can we get maximum height? At maximum height, we know that what? The velocity there is what? 0. So we know the final velocity at maximum height. We know the initial velocity. Okay, then we also know the time it takes to get to maximum height. And we've been asked to, so we know time, we know initial velocity, we know time, how do we call it? The initial displacement, and we want to find the height at the maximum point. Which of the three formulas can we employ?
The last one.
Yes. So we can employ the last one because we know the body started from 0. Okay. We know the velocity in the y direction. We know the time to maximum height. And we also know the acceleration. We know the time to maximum height. So we can easily find that. So let me clear the screen. I'm going to clear this part. Yeah. So we keep this formula here. And then let's prove maximum height. So that's going to be S is equals to the initial displacement is 0 because the body is coming from the ground plus, so take note, when the body is not being kicked from the ground, okay, then the displacement will not be 0. So you have to include it in the proof. Okay, so S naught plus your velocity in the y direction will be what? That will be V naught, okay, sine theta, okay, times the time to maximum height is what? V naught sine of theta over G, okay, then minus half gt squared. So that will be half G times what? V naught sine of what? Theta, sine of theta over G all squared, okay, all squared. Okay, so now let's expand and simplify this. Okay, if we are to expand and simplify this, I'll leave an aspect of the simplification for you to do. Okay, so okay, so Eric says network is disturbing him. He's not getting some parts. The video will be available after class, so no need for fears. Okay, good. Now, yeah, so let's simplify this. You see, we have the same quantity here, V naught sine theta and V naught sine theta. So that will be what? V naught squared sine what? Sine squared what? Sine squared theta, okay, over G. And then this will also be what? When we come here, when we square, this will be squared, this will be squared, this will also be what? Will also be squared, okay? That's if we expand with the squares, okay? So which means that we are going to get, and then one of these G will cancel this, one of this G here, okay? So we'll end up getting what? V naught squared sine squared theta, okay, over 2, there's a half here, so over what? 2G, okay? Yeah, and by simplifying this, we can get V naught squared sine squared theta over G, okay, into bracket what? 1 minus half by factorization, okay? So if we simplify this, this should simply give us 1 minus half will be half. So we will have V naught squared sine squared theta over what? Over 2g. So that is the formula for what? The maximum height. So if you like, this is S. So ideally we could have made it. It should have been what? S maximum. Okay, S maximum. Okay, so that is S maximum we are dealing with. So X maximum 2 is V naught squared sine squared theta over what? Over 2g. Okay, so well noted. With these formulas, we want to move on to the range. Range is in the X direction. Okay, so we are going to use a different approach because in X direction, acceleration is 0. You cannot employ kinematic equations. So let me clear the screen first. Okay, then we look at S component 2. So in S component, we know acceleration is what? Is equal to what? 0. Acceleration is 0. So if acceleration is 0, and we are dealing with a constant velocity scenario, then it means that we can employ the basic understanding of what? Velocity, which is change in displacement over what? Change in what? Time. Okay. So if you want your range, change in displacement is just going to be what? Velocity times what? Your change in what? In time. Okay. Now, the displacement, the range we are talking about here is your change in displacement in the X direction. Okay. And then the velocity in the X direction, if you remember, is V naught X, which is what? V naught cos of what? Cos of theta.
Cos theta.
Okay. Then the time here. Okay, let me draw this thing so that you get it better. The time here we are dealing with the range. The range starts from this point to this point. So it means that the time we are dealing with is the time in the X, which is the total time. Okay, the total time. So it's the total time we are dealing with here. So this change in T is the total time, is the capital T, which we found earlier. Okay, so this will now become what? V naught cos, okay, theta times the total time, which we calculated. We had what? 2 what? 2 what?
2 V naught.
2 V naught. I'll miss with it. So 2 V naught. Then we have what?
Sine theta.
2 V naught sine theta over what?
Sine theta over G.
Over G.
Over G.
Yeah, thank you very much. So this will lead us to get what? I'm seeing V naught here, V naught squared. Okay, times 2 sine theta cos theta.
Cos theta over G.
Cos theta over G. Okay, good. But we all know from trigonometry, 2 sine theta cos theta is also going to be what? It's going to be what?
Sine 2 theta.
Sine 2 theta. Okay, double angles.
Sine 2 theta. Yeah, it's sine 2 theta.
Double angles. So sine 2 theta over G. So that is the formula for the range. Okay, that will be the formula for the range. Okay, so it means that now we've derived all 4 formulas which we need in analyzing a projectile motion. Okay, so once you are given a question, all you need is your V naughts. You can see that all the formulas require V naughts and then require theta, and of course your G. All the formulas need these values. Okay, good. So I think subsequently there are some examples, okay, which we are to solve. You make use of the formulas to solve them. Let me go down there a bit. Okay, so all of them have been proved on the slide like that. So there's a question like this. It says if CR7 kicks a ball at an angle of 40 degrees, meaning theta has been given, provided. So theta is what, 40 degrees. Okay, if the ball takes off with initial velocity, so V naught is 25 meters per second. Determine how high the ball can reach, okay, and the time it takes to reach the maximum height. So we have to find S maximum, X maximum, and then T maximum. You are going to find that for me and give me the answers. So find X maximum and then T maximum with the formulas we just proved. And then finally, it says if the team striker stands 50 meters from him, will the ball reach the foot of the striker? Okay, so first you have to find the range and then you can do that evaluation. So here we are going to look for the range, okay? That will be the range, if you like. That will be the change in S, okay, in the X direction or your R, okay? So find these three quantities for me. Make sure you are solving. Okay, Oscar, you're asking if always in relation to the range, displacement in the horizontal, hence acceleration is equal to 0. Yes, so let me explain that again. Okay, the reason why acceleration is equal to 0 is because the velocity in the horizontal direction, that's horizontal component of the initial velocity, okay, is not lost. It keeps the velocity. The velocity does not depreciate. There is no force retarding it to slow it down. Okay, so the velocity remains constant. And that is the more reason why the ball, when it goes up and comes down and even hits the floor, if the floor is a smooth surface, the ball will keep what? Moving. Okay, because V naught X is constant. Constant means that it has not changed, it has not varied. And the only way velocity will vary is when there is acceleration. But for the very fact that the velocity is not varying, then it means that acceleration is equal to 0, means there is no acceleration in that motion in the X component. Okay, that is the whole idea behind that. Okay. Yeah, so I'm waiting for your solutions. Okay, so I have, Danny has given me H maximum to be 62.8. Please don't be waiting for me to solve for you. I've showed you all the formulas, so you should be able to just substitute and calculate. So don't sit down waiting that Cell will solve it for me to copy. So T maximum is what? 3.28 seconds. So I'm waiting for more solutions. It's left with the range. Yeah, it's left with the range.
Sir.
Yeah, type it for me,
Hello,
please.
sir. Yes, I have x maximum to be minus 12.9. I don't know, is that the correct answer?
No, it can't be minus.
Okay, then, okay.
So check the mode of your calculator too. Okay, check the
Oh,
mode.
please, is okay, 12.9, right?
Yeah, so range will be 12.
Positive 12.9.
Yeah, 12.9 meters.
I use acceleration due to gravity as 10.9.
Okay, that's fine. Yeah.
Okay.
Can I get some other answers, confirmation answers? Please take note. I'm taking note of those who are participating in class. I'm taking note of them. So,
Sir,
Mohammed says we are getting the range to be 20.497. Let's get another answer. Maybe we'll have to solve the range together.
hello, sir.
No, sir.
Yes. Yes.
The range is 62.80.
Okay, so 62 point. Yes.
Sir,
Yes, I'm listening.
the T max. This is saying the T max is 1.6.
1.6.
Is that the right? 1.61. 61.
1.61.
To 2 decimal place.
Okay, so now let's solve
Yes,
it
to 2
together.
decimal place.
Let's solve together. Okay. So want to solve. So initial velocity is V naught is 25 meters per second.
Okay.
Then theta is 40. So let's go back and apply our formulas. Okay. So for time to maximum height, this is it. So that is going to be 28 sine 28 times sine of what? 40 sine of 40 degrees over, if you like, 10 or 9.8. Okay. So some of you on your calculators, you may want to punch sine 40 You may want to type this. Don't do that. Sine 40 times what? 28. Okay. Please be careful. Rather type the 28 first times sine 40. Okay. Over 9.8. When you do that, what do you get? When you type 28 times sine 40 over 9, what do you get?
Sir,
Yes, what are we getting?
you get 1.63.
1.63. So
Hello, sir.
1.63 seconds.
Sir.
Okay. Yes.
Hello, sir.
Yes. Yes, I'm listening.
Hello, sir.
Yes, go ahead.
This is yes. My battery is running low, so I can just log out at any point in time. So if I log out, please know that my battery has been down.
No problem, no problem.
Sir, please, in the question, the initial velocity was 25.
It's 25, eh?
It's 25.
Okay, so that's
Yes.
25. Okay. Does it change the answer?
Sir, no.
Okay. I think you use the right value, so we don't have any problem. Okay. So this is it, 25. Then if you want the maximum height, this is the formula for the maximum height. So that will be 28 squared sine